Oh, this is one day. Today's topic is a general use of standardization. What is a standardization? It this standardization works to eliminate the unit, right? Let's see. General uses of standardization. Standardization is not only limited to normal distributions. It can be applied to any kind of random variable, any kind of data, okay? Standardization often plays a significant role in data analysis. It is a very useful tool in data analysis because it standardization introduced for purpose of calculating the probability of a normally distributed random variable, but standardization is commonly used in general to eliminate the unit of measurement from data. We usually denote it by G. G is a standardized variable. What? G equal to, we have a data or random variable x minus its mean, E of x, and its standard deviation, right, of x. So this is the form of a standardization. Therefore, the data set comes to unitless. Every data has a unit, but we do not want to keep that unit, then we can standardize it, and we have unitless scores, unitless data, in order to compare several kinds of data, okay? It is an important note, not only standardized variable follow normal distribution, not all standardized variable follow normal distribution, okay? When a variable is standardized, the standardized variable maintains the same distribution as the original variable, let x. Then x has some distribution, then what? G, standardized variable, also keep that distribution. For example, random variable x follows a Bernoulli distribution. Then the resulting G after standardization will also follow Bernoulli distribution. In other words, x tilde Bernoulli with p is parameter, okay? Then g is what? X minus its mean is p in this case, Bernoulli case, and divided by standard deviation, square root variance is p1 minus p. So this one is standardized one, has same distribution as x. So G follows Bernoulli distribution, okay? Only mean and variance change to 0, mean is 0, and variance is 1, okay? So you can use standardization anytime you want. Let's see this simple example. Schools evaluated by two department heads, A and B. They are head A, head B, okay? Different department. And A has 4 persons and B has 3 persons. They score, A and B scores for evaluation, so 100% point. Kim has 55. To Lee, A gives 50. For Park, 60. Moon, 55. That kind of his scale. He has a scale, scoring scale. Okay? Relatively some low scores. B, department head B gives to Choi 70, 80 to Jung, 90 to Liu. Okay, 3 persons. So everybody can see A and B have different scales. So let's see, A, head A mean for 4 person 55, and its standard deviation as 3.5654. Department B, his mean 80, and the standard deviation 8.16. Different mean, different standard deviation. So separately for A, for B, HR department most standardize the evaluation scores given by A and B, right? A score 55, this one. 55 minus its mean, 55, its standard deviation 3.54, then 0. How about the 60? Park. 60, sorry, here is 60. Okay, it's an error. 60 minus 55 divided by its standard deviation 3.54, 1.41, right? For department head B, Choi, 70, 70 minus its mean, 80, divided by 8.16, it's minus 1.23. For Jung, 80, his score can be standardized minus 80 divided by 8.16, it's 0, right? So all persons, 7 persons scores are standardized, in other words, unitless. Then by standardizing the scores, they can determine that the overall ranking of the 7 evaluation scores. So which one is biggest? This one, Park. Okay. Next is Ryu. Here, 1.23, 1.23. Lee has minus 1.41. Okay. They can order 7 persons. Additionally, the standardized scores of 7 individuals can be converted back to a score with mean 70 and standard deviation 5. In other words, in order to report to the CEO, okay, they can, HR department can convert back to a score with a mean 70 and the standard deviation is 5. In other words, for example, this guy, Liu, 1.23. What is it? Liu minus what? 70 divided by 5. Then from here, from this equation, Liu's score will be 70 plus 5 times 1.23, right? From here, this equation. So his score is about 76 for all persons. All persons, they score, their standardized score can be converted to another value, another score. Okay, this is how to use standardization in your data analysis. Okay, okay, that's it. It is short, but I'd like to add some other things here. This is just a fundamental context of statistical theory. So I explained, introduced Bernoulli distribution, binomial, and normal distribution among the probability distributions. But you have to understand basic terminologies and the concepts in statistics. Population, sample, mean, variance, random variable, expectation, and the probability distribution of a random variable, say X. Okay? There are several useful probability distributions, say Poisson distribution, geometric, exponential, chi-square, T distribution, F distribution, and so on. There are many others. But this is just, say, basic, intermediate distribution function. But T distribution, I will say about the T distribution later in order to help you to understand the basic flow of statistics. Okay? I am emphasizing what you have to get the frame of statistics. But next time, I'm going to explain sample, theoretical sample. That is very, very important for you, I think. So coming soon, later. Okay? This is it today. Thank you. Bye.